I have a small story today, and it starts in 2009. Back then, I had a really nice, cushy job as a Java backend developer, as maybe some of you my age have had before doing Android development. I'd actually gotten a bit bored at work, and I started developing apps on Android as a hobby. So I was looking for ways to get better at it and perhaps turn it into a career eventually. And that's when I started attending my local Android developer user group. And that's in Montreal, Canada. Communities like that in general, I think, are really magical, right? You go in, you meet new people, much like today, you come up with crazy ambitious ideas. You try to build them in hackathons, and you just end up learning a ton of new cool stuff. And before long, I became a very active member of this community. I started giving talks, I started volunteering in workshops, organizing some hackathons. I couldn't get enough of it. And then a couple of years ago, I joined something called Osmos Academy in Montreal. Now, Osmos is a nonprofit that was founded by good friends in the community. I met with the Osmos founding team originally attending something called Wear Hacks. You can see the banner of the way back in that photo. And as you could guess, Wear Hacks was a wearable technology hackathon. So I attended Wear Hacks with a bunch of friends, and our idea back then was to experiment with various wearables. And Macy, right before me, mentioned how it's hard to find input devices for VR experiences. Back then we were talking about cardboard. So our big idea was, what if we could use some of these wearables as input devices for VR experiences, for cardboard or any other experience? So we started experimenting with that. And a lot of all this interest, like we learned a ton of things. And this interest in VRs and wearables was carried over when we all started volunteering for this Osmos organization. So the general idea behind Osmos is to teach social-minded volunteers about emerging technologies. That's a big picture. Osmos puts a strong emphasis on improving accessibility to emerging technologies. And the charter you see here emphasizes 3 other core values. So that's engagement, inclusion, and diversity. So that creates a powerful mix that's going to attract a lot of volunteers from all walks of life. And these are usually people that are motivated to learn and very motivated to make a difference at the same time. So when we started up Osmos, a question came to us. We love VR and we love AR. We love wearables. We love IoT. We'd like to do something with all of that. But how do you actually build up social good with that kind of tech, right? We looked at direct applications of it to get inspiration. So VR can be an awesome learning tool. If you think about geography in this case, the VR edition of Google Earth is an awesome example. What could be to kids or whatever, a boring topic, can turn into an eye-opening exploration of the world. You're like this giant overseeing the Grand Canyon or various super interesting locales around the world. And you feel a little bit like Superman. You can fly into orbit and just come back down. Really an awesome way to learn about the world and really open up your eyes to, the Earth and how, we're little fragile things on this planet. You want to create a time machine to explore historical events. So this is exactly the type of installation here that's hosted at the Palace of Culture and Science in Warsaw, Poland. You can build any types of simulation with VR. If you want to navigate to the heart of the atom, you want to see a math equation come to life, stand inside a running engine, like the possibilities are crazy. They're endless. And there could actually be more benefits to using VR and presenting material in that way. And this is a link to an article by Chris Nicholson, who's a researcher on Shopify's VR team. I always follow with a little disclaimer, I'm not representing them here, like I'm a good old Android mobile developer there. But in this article, he explains that humans are visuals and spatial learners. So the way you have to sort of think to illustrate that and really get a grasp for this, the example is to think back on your own high school years. I'm guessing it's probably difficult to remember most of the names of your classmates back then. But chances are, if I asked you, you could draw a rough floor plan of the actual school. And the thing is, if you apply that to VR by creating a virtual space where students can explore and learn about the world, you'll leverage this sort of spatial learning effect. In the field of journalism, we've seen compelling uses of VR as well. So what's life like if you're fleeing from a war zone? Or what's the daily life of a volunteer in a far-off region of the world you're likely never going to visit, right? It's really interesting to find out about these things. Finally, we can think about the field of healthcare. there's been a lot of research on how to use VR and apply it in that field for treatments. So you can relax patients suffering from chronic pain. Exposure therapy can help to treat phobias. There's rehabilitation therapy that's also very interesting. There's a lot of promising areas of research for healthcare and VR. So at Osmos, what we did is we focused those efforts there on healthcare first. So our first project was a project called VR Passport. So we launched that in 2016. The idea was to bring virtual reality experiences to kids in hospitals. So for them, it was a way to escape their environment a little bit, learn about the new technology, and just have fun, right? So for these kids, even a small break from treatment was a really big deal. So in preparations for these hospital visits, what Osmos did is we held various workshops. So we had VR content creation workshops and courses. We teach people how to build Google Cardboard VR experiences with Unity specifically. We also had augmented reality content creation workshops. At the end of all the AR workshops that we held, were over a course of a month, we ran a Project Tango hackathon. So Google sponsored us back then. Our participants actually got to develop on actual Tango hardware. It was really interesting. People learned a ton, they loved it. And we also had kid-friendly workshops where participants could decorate Google Cardboard headsets. So these headsets were a huge hit in the hospital visits. And it might sound silly, but that's really where a lot of my inspiration came from when we moved forward these projects. I was starting to pay attention to how creative people got at our events. So I was seeing participants from all fields, right? Artists, designers, crafters, developers, even a cinematographer. So I estimate that a solid third of the people we had in the workshops were definitely not from a technical background. And at the end of the day, everybody was learning something, and everybody found a way of contributing. That's the most important part. You didn't have to be a developer to contribute. So where do you go from there, right? Like, how do you take a pool of very enthusiastic volunteers and you empower them to do more? So based on all the experiences we had with the VR Passport project, some ideas came up for us. And the big general idea for us was to provide a toolbox to the community. So everybody could learn something new and everybody could participate. So then the question becomes, what kind of projects have something for everyone? So one example of this is this Audi mixed reality experiment. So their idea was to scan a real-life model, like a little sandbox, and drop the players into it with a car, a simulation rig. So if you watch this clip, step back a bit and put that community organizer hat on. That's really a great project, right? You have kids that can be playing around in a sandbox, just doing whatever they feel like. You can build a race car simulation around this with a rig, an actual wheel, like woodworking is involved, like actual controllers, physical stuff. You have 3D modeling, scanning things with a Kinect, programming the VR simulation. You have a ton of skill sets required here, and that's the key, right? You can involve everybody in a type of project like that. It's a bit ambitious, but you don't need to be an engineer to participate in a project like that. So it's a lot more open to everyone. Another big source of inspiration came from this game. So that's Keep Talking and Nobody Explodes. It's a co-op game. One player is a technician in a virtual room with a ticking time bomb they must defuse. And the other players are the experts on the other end of the line who have the bomb defusing manual. So the experts can't see the bombs. The technicians don't have the instruction manual, right? So this game is all about communication between the different players. And I personally believe that's why it's often cited as one of the best VR experiences out there. I think it's important to point out also that the concept even works without a VR headset. So, and that's important because VR headsets have one big downside. They isolate the viewer from the people around them. That's not great. When you're creating a mixed reality experience, what happens is you can solve that problem. You create suddenly a shared experience, regardless if somebody's in VR or not. And that's the kind of experiences we wanted to build, and that's where our focus went when we were thinking about this toolbox. We wanted to go very large. So mixed reality projects for me, and that's my own definition of the term, it's not Microsoft's or Google's or whatever, it's about enabling people to break that VR fourth wall. And that's something we were really after when we were looking at projects. All right, so technical bits now. I'm going to show you some of the things that we've been putting into our own mixed reality toolbox to empower the volunteers. The big hope, obviously, is that you bring that back home and perhaps share some of these ideas with your community and play around with them yourself. So one of the things we're using in our toolbox is the Android Things platform. So having Android Things available allows you to create connected physical models, and you can interact with these models both from VR and AR. So that's the big reasoning there. Legos are also very much a part of our toolbox. They allow you to prototype the physical side of the mixed reality experience. And the fun thing about Legos as a platform is that you can go pretty far with it, right? So this is a kit that you can get from a company called Dexter Industries that allows you to use the Raspberry Pi as the brains of your Lego Mindstorm builds. One of the downsides of this kind of approach is cost. Lego Mindstorms are still pretty pricey. There's a few Lego alternatives for robotics, like something like WeDo that Lego makes for educational markets. But they're still pretty pricey, and the connectors between the different Lego sets actually are not compatible between Lego official parts. So it's still a bit of a hassle to use in community projects. What we did to supplement Legos and sort of break through that problem is we experimented with 3D printing our own connector parts. So 3D printers right now are at a level that you can get pretty good results that they actually print workable Lego parts. That was not always true. So if you want to use, say, 3D printing in your own toolbox, Monoprice sells this very decent little unit for $220, I think, last time I checked. The thing to note is that 3D printing can get to be a bit of a time sink when you first get into it. But what's nice about this specific printer, besides the price, is it's pretty much plug and play. So you get it out of the box, you don't have to assemble or anything, you plug it in the wall, you just need a reel of plastic, and you can get started printing stuff. You will have to be patient if you want one of these. It's usually out of stock every time I check. But they do have production runs that come pretty regularly. For AR experimentation, we focused on using phones as our magic window. Smartphones with cameras are the norm these days, right? And they're powerful enough to provide AR with the right libraries, which we'll look at in a minute. Then on the VR side of things, Unity in our own workshops has been the go-to solution. Everybody basically can learn it. What's great with Unity is also it adds an abstraction layer. So once you know Unity, you can write content for Oculus, HTC, Daydream, what have you. Right. So you might be thinking at this point, okay, he's got 3 platforms, Android Things, web, other things. How do we get them to talk to each other? And the solution, the quick MVPs, is Firebase. So Firebase database specifically. This is not a Firebase talk, so I'm not going to be going into details. But if you're not familiar with Firebase, the big idea is the following. It's the source of truth, Firebase DB, for your model. It lives in the cloud. And your clients will subscribe to it and push updates to it. And whenever one client pushes an update into Firebase, the others get notified of the change and can react to it. And usually it's fast enough that you can get pretty nice experiences, even in VR. You're not going to get ultra low latency out of it, but you can share a model in a very simple way. And especially for community efforts, it's really number one for this kind of stuff. All right, so we're going to look into a bit more Android Things and how we used it in our own toolbox. So Android Things supports the Raspberry Pi 3, and it's originally what I went with. Now, if you start your own Android Things project tomorrow, I would recommend grabbing this board here, the MX7, instead. Reasons for that: it's a lot faster to develop with, it's generally better supported. Like Dave can talk to that here, but my understanding is that Google has first level support for MX7s, and Raspberry Pi, it's a bit of a longer cycle. That's the main reason for that. The big point, though, for development is that this connects with a USB cable straight to your computer. So it's a lot easier to develop and run code on it in general. For the Raspberry Pis, you often have to, you have to upload your programs where you have Wi-Fi, and that's kind of slow. And so if you want to just get quickly running things and have fun, this board is a lot more pleasant for that. All right, so an example. So let's say that our mixed reality experience, we have a player that's exploring the universe. We're going to have 2 roles: explorers in VR, which are going to wear the headset, and scientists back at the lab. So this is our lab, and this is where our scientists are going to assist the interdimensional explorers. So in this lab, we're going to have a portal featured here, and we're also going to have a conveyor belt. And she's very into it. It features a conveyor belt that scientists can use to transport objects and people between dimensions, right? Okay, so that's our big idea. So let's start with something very simple. We want to add a little LED to our model. We're going to want to blink that LED so the real life players can see what's going on. Electronics for this are very simple, but it's a good starting example. So you write into what's called a GPIO pin, and you control the LED that way, on and off. I added a resistor, personally, to the graph. Sorry. Let's see how to control this pin on the software side. So the key is to get a reference to the pin with the Android Things Peripheral Manager service. So I'm not going to dig too deep into code samples here today. I expect this is all stuff you can find on the various intro websites for the various technologies, just to give an idea of the complexity level. That's really what that slide's here for. So you grab that Peripheral Manager service, you grab a reference to that pin, and you can turn it on and off by setting the value of that pin. In this case, I used RxJava to make that LED turn on and off every second. That is definitely overkill. Don't do that. I just like RxJava. That's my shame. So to make things more interesting with the model, we can also add mechanical interactions. So here in this example, what I used is a small DC motor. I hooked up with some connector parts, like you don't see it here, but there's actually some of those 3D printed connector parts that are used in the final model. And so that's helped to move the conveyor belt backward and forward. If you're curious, there's also like a gear up and down system right here that's pictured. So it's kind of fun if you want to learn like the basics of Lego mechanical. So that the gearing system allows you to have a motor that spins perhaps a bit faster than it should, and to make the conveyor belt go at a speed that's a bit more acceptable, for example. Anyway, so the electronic side of things here is less trivial this time around. The main reason that it's a bit more complicated is to isolate the motor from the actual logic circuits, right? The power requirements for a DC motor are different than those for a Raspberry Pi. By using the component you see here, the L293D chip, you can make sure that turning on and off the motor won't mess up your Raspberry Pi. So if you wanted to build your own, you definitely want to look up adafruit.com. They have really great tutorials for these types of projects. They have really great tutorials on how to build your own little robotics platforms as well that can definitely be run off of a Raspberry Pi or the MX7. And they also have like the add-on boards that you will need to make that happen. And they have like a ton of really nice documentation, full on everything, stuff that you could cover in a talk that lasts 40 minutes on its own. Everything is there, so that's a really good starter point. On the Android Things side, coding-wise, this is how you turn the motor on and off. PWM here stands for pulse width modulation, and that's the, it says click here. There we go, a little animation, I think, right. So that's the method that's used to control the speed of the motor, the PWM. So the GPIO pins 20 and 21 are the ones I grab here, and I use them to control whether the motor goes forward or backward just by flipping the booleans there. So if you're new to electronics, who's unabashedly new to electronics here? Or like total noobs? Everybody else knows electronics? I'm talking to a crowd of confirmed professionals? Okay, fine. So if you are starting out, like the only two people that admitted to this in the room, Android Things website has a really great Hardware 101 section and a very nice beginner section. I had not done any electronics in at least 10 years, I want to say. I visited that page, everything came back to me. I learned new stuff. Really good place to start, and it'll give you the essentials. The other good idea here is to get something like a Raspberry Pi starter electronics kit. I got mine from a local electronics store. There's hundreds of these online. You can get some off of Alibaba for 10 bucks each. I mean, a good Pi starter kit should have a couple of things. It should have a detailed manual to teach you the basics, and it should have like a nice range of parts. Little engines are nice, little shields to sort of make things simpler. There's a ton out there, but they're fairly cheap, and they're a really good source of learning. All right, so at this stage, we can create the Lego models with basic components for real-world interactions. That's working fine. So let's see how to augment them. Right, we're going to try to add the basic portal effect I referred to earlier in that doorway. And to complete the illusion, we're also going to be trying to add virtual objects on that conveyor belt that would move along when something happens in VR and the motor starts itself. So you can create this illusion, right, of like virtual objects moving alongside the actual physical conveyor belt going forward or backwards. All right, so originally my approach was to use Google's Project Tango. And it's a very nice stack. It allows you to, it runs on custom devices, I should say first, that have extra sensors and cameras. So it allows the device to keep track of where it is in space with 6 degrees of freedom. Like in 3D space, it knows where it is, it knows what it's looking at, and it also knows if it's moving about in a room. It's pretty accurate. It can see what things are in front of it through a point cloud data feed. So when you write software for this thing, you find out where points are in front of you, and you know the exact dimensions in space. So it allows you to do very precise, very accurate AR experiences. While Tango is really great, it is definitely not what you can call accessible hardware for most people. So for our own workshops, what we ended up doing is going with Jérôme and Alexandra Etienne's 3JS web AR extension that's pictured here. So they've had great success building AR scenes at 60 frames per second rendering on 2-year-old Android phones. And the library is web and JavaScript based, so it makes the technology accessible to a wide range of people. It's perfect for the community projects we were looking at. And as a side note, though, if you're still interested and curious about Project Tango to do more precise work, I've done a talk on it way back at DroidCon New York 2016. So this talk is going to show you how to get started in building an AR magic window using Tango. So if you're curious about that, I'm always ready to answer questions about that after this session. And there's some nice things you can do with Tango for sure. Now, for us, though, right now, the first thing we want to do is get Ar.js working with a visual marker. So the library uses image recognition to find the pattern in a video feed, and that's how it's adding and anchoring 3D on top of the video right here. So you also need to make a map of the virtual model onto the physical one. So Nina. Yeah, that's typically how it works with kids. 7-year-olds are pretty good at maintaining their bubble of virtualness. All right, so calibration phase involves placing the marker on the actual model. The key that you need to remember here is that the size of the marker determines scale. So your marker here is 1 unit by 1 unit, and it lays flat on the X and Z plane. You can see on top of it a 1 by 1 by 1 cube that's sitting on top of the marker. If you ignore the configuration boilerplate you're going to see here, this is all the code you need to add the transparent cube and place it on top of the marker. If you look at the code, we're also adding an axis helper object on the scene. It's pictured here. I don't know if the picture comes out nicely, but you can see the green, red, and blue axes that are based on the marker next to the cube. So it helps you sort of see where you're calibrating your things. If you're new to 3D, the main thing to remember about creating 3D scenes in 3JS, which is the library that comes alongside Ar.js, it's fairly well documented. There's a lot of code, a lot of good examples out there that you can sort of take from. They're all open source. And in our own experience with the community, people tend to pick it up pretty quickly. All right, then, to map our virtual objects onto the video feed, we'll take real-world Lego measurements, pictured here, and we're going to add them into our simulation. So the AR marker I printed for the demo measured 32 millimeters on each side. I know this just because I printed it to that specific side. It could be inches, whatever. But knowing this, what you can do then is you can calculate your virtual Lego measures, right? So your marker is your frame of reference. So in this case, a unit of 1 in our virtual world is 32 millimeters on each side in height. Knowing this, you map out with real-world Lego measurements, and you can create your AR window that will match roughly on top of your model. Right. So at the end of all this, here's the code that adds objects to the scene. So I can go over it a little bit here. With 3D code, if you're not familiar with that stuff, the big things are usually whatever platform you're on, you're going to assign a material to an object that's going to be your actual 3D geometry, and you're going to add that object into a view hierarchy of objects. And your renderer is going to pick that up. So you have different material settings. You can have solid materials. You can have transparent materials. So we see here the portal section sets up an object with an opacity of 0.5. So you have that kind of stuff going on, right? Okay. So now at this stage, we've built the real-world component of our mixed reality prototype, where we have our Lego that can animate itself physically. We have an AR window on top of it. So we're going to look at the virtual component and how that works. So So what happens on the other side of the portal? At that point, I was out of ideas, so I reached out to my creative director, who's right now sitting in the crowd, humming along at whatever she's doing. She's having fun. So this is Nina, my creative director. Lovely, lovely Nina. And our idea at that point was to have Mr. Halloween guy that wanted to go say hi to his friend Birdie Buddy all the way in the corner. To do this, we decided you need to open 4 doors. So you have to look at the little white Lego sticks and imagine these as doors, right? Did I mention I am not a 3D modeling artist? Okay, now you know. Right. So the person outside the simulation will be helping Mr. Halloween guy, who you have to imagine being the player wearing the headset, when they face obstacles along the way, those doors. So in this case, the examples I'm showing you are built for Google Daydream with the Unity engine. Again, if you're using Unity, you can very easily plug whatever you develop into another framework, say HTC Vives or Oculus, and make a VR experience in those frameworks, on those devices. So, as far as our community goes, this is our recipe for success. Daydream is cheap enough and easy enough to get. Unity opens things up to developers of every level, so we've had really great success with that. That said, to set up your own copy of Unity for Daydream, specifically Daydream development, right, which is based on Android, you're going to need to follow the instructions on this page. It's going to get you most of the way there when you want to start your development. With the latest version, when I checked, of the GVR Unity SDK, the best setup was to use Unity 5.6, which was at the first time I did this, it was beta. Now it's out of beta this summer. And they've actually moved on to Unity, and they only use a numbering scheme, which is the year. Unity 2017 is the latest one. Last I checked a few weeks ago, that's not the route you want to go. You want to go with slightly older 5.6 right now. That might have changed in the meantime. So it's always something you want to check. Also, if you're a day-to-day Android developer, this is the time where you take out your camera, your cell phone, take a picture here. There's a couple of issues to be aware of, but that's if you're an Android day-to-day developer, right? Under the hood, the thing is that Unity's latest version, or at least 5.6 I should say, was expecting an older version of the Android SDK tools. So that meant if you wanted to be able to develop day-to-day and not be crippled by this old SDK, you wanted to install the SDK for Unity in a different folder. And there's also a few issues that are sort of explained in these links around setting up the Daydream controller emulator. For it to work, you need to edit a very specific C# file and change one line in it. Nothing hyper complicated, but if you're just setting up and you don't know these things, you're going to lose hours, if not days, just finding this out. So take a snapshot of this. It's still a good idea to save yourself some time if you're going to be starting on this and you want to not kill your Android install in the process. My own personal recommendation, step 2, is to install it's new, relatively new. It came out last winter, I think. It's JetBrains C# IDE Writer. So Writer has a very nice Unity plugin you can use. You're going to get all the powerful features you're used to with Android Studio, and it allows you to avoid the default Unity IDE editor. It's not really worth your time. If you compare and you're used to Android Studio, go with Writer. You're going to have a much more fun time. It allows you to refactor code. It allows you to follow up things. Much better experience. Now, first time using Unity, spend a bit of time on the Rollerball tutorial. It's going to teach you the basics of the world editor. You're going to see how to add 3D objects to a scene. It's going to teach you the basics of camera, lighting, and material. All good stuff, even if you're all new to game development. You're going to add scripts to game objects with this demo, and you're going to find out also how to apply physics. This is an hour or 2 of time that's really well spent before you dive into VR. VR is 3D, and the underpinnings of it are these basics. But yeah, 1 hour or 2 for somebody slightly experienced in development is going to be enough, and you'll be up and on your way. And then that said, once you are familiar with Unity, using the Google VR SDK is pretty straightforward. The first thing you're going to be doing is adding a prefab to your Unity scene. In this case, it's the GVR viewer main prefab. You don't need to remember that. You're going to see that in the tutorials for Daydream. But you add this object to your scene, and that's about it. That's all you needed to do to get Daydream working. Once you've done this and you preview the scene in Unity by pressing the play button up there, you're going to have full stereoscopic 3D. Granted, not much to be seen here, but this was full 3D, and you had the visual correction in the lenses, and you have everything set up, and using the mouse, you can actually look in different places in the world. So you're already in good shape to do VR. Now, to use the Daydream controller, which is a big feature of the Daydream platform, if not the biggest one, you're going to add the GVR controller main prefab to your scene. Again, fairly simple process. And once you've done that, you find the GVR controller pointer in your scene there. You add that to the player game object. Player game object in Unity is the actual sort of, in our case, the headset wearer, or if you're not doing VR, it's like the perspective from which you're running the game, right? Then once you've done that, you install and bring up the controller emulator app on a real device. But before that, thing to note is that once you've added the prefab to the scene, you can see it. So you can scroll up to it and sort of see, and this is what the player is going to see when they're going to be in their VR experience. And then what you can do is bring up an emulator, and you run that emulator app, and this allows you ultimately to have a real device, either a phone or the actual Daydream controller. And when you're going to be running this in your simulation, you can see now, this is an example. I was running this with the actual Daydream controller in my Unity. So for development, it's really great, right? You can move around, you can test things out, and with the mouse, you can simulate head movement, so you don't have the hell of compiling a new experience and taking a few minutes to put on the device to find out, oh gosh, I screwed up that one line of code, I have to try again, right? Like the development cycle for Unity is very user-friendly. Right, so let's get back to our original scenario with Mr. Halloween guy and Birdie Buddy, right? So we haven't put these doors in the scene yet, so again, you have to use your imagination. How do we move about the board to get to our friend right here? Baseline locomotion mechanics in VR is teleportation. So this is a link to a very detailed tutorial on how to implement this in Unity. I'm going to go quickly over the basics so you have an idea where you're going if ever you try this at home. So general idea with Unity is that when you want to do things, you assign scripts, the code, to an object that will react to things, for example. So in this case, we're assigning a script to an object that will react to being clicked in the game world. Using an event trigger component, this is where you register to handle these clicks on these objects. So here, the pointer is going to enter and exit a tile, and that tile is going to change color to react to actually being hovered on. And when the click happens, the code to move the player object in the scene is executed, and that's how the teleportation happens. And that's your basic, don't want to get the user sick in VR, teleportation, moving about mode. If you're not aware of this yet, you probably want to stay away from having VR users actually move about unless you're simulating a car, because that's how you're going to get people seasick really, really quickly. Like our brains have to sort of have a framework for us just moving in space. If we're moving on a chair, we think car, we're okay. If you're pressing a button to make the player go forward, that's like a really quick way to get people sick. All right, so we have locomotion in place. Let's see how you could add locked doors to a scene. So to make things more interesting, we have color locks on these doors, right? So the example here is to see how we can unlock the doors with the right key. Make the game a little bit more interesting. And this way I show you the basics of creating a full experience. So to do this, what we want to do, the way we're going to simulate having keys, is we want the player to hold the right color cube in their inventory when they click on a door to try to get it to open. So for this, we're going to need to come up with a way for players to pick up a cube or pick up a key, in this case, right? And use it then on a door by clicking. And then when it happens, we're going to have the door simply open. Right. For first thing, how to pick up an object. So we know how to point to something and click on it and react to that, so we're going to use that. But then we also need some sort of inventory here, right? And we need a way of telling the user, hey, cool, you just picked up this specific color of a key. So what we're going to do is we're going to add a sphere to our scene. And we're going to stick it right next to the controller where the user can see it. And we're going to change color when we pick up the right color cube. right? If you were being a bit more fancy, you'd draw a key here and you have a texture and all that. I'm not really about being fancy right now. Just like learning the basics is, good enough. So we want a pick key method to the behavior script of our object. So when it's clicked on, we'll run that and we'll add the key to the user's inventory. So I show here how to do that. And once that's done, it's really hard to see where those videos are in the preview. So once you have that, this is your script that's going to do this. Like at the bottom here, you can see very simple stuff, one-liners all over to add that behavior. Right. So when you have that, when you want to assign it to all the objects, right? So that all of them will sort of assign a color to your inventory when they get clicked on. And I have to admit, at this point, I'm really mixed up as to where I am in the slides that explain exactly what's going on. Right. So you just click on. Okay. So at this point, you can pick up a key. So you're going to want it to use to open up the doors. Wait, let's go back. I just want to show people the actual little video. So this is a code, and I don't show an example of this running. Right. Sorry about that little awkward pause there. There we go, okay. I just wanted to show like the end results from all these little changes. So you're going to point to something, you're going to click on it, that sphere is going to grab the color to represent what you have, and then once you have that, you're ready to go to click on a door, and you know which color click you're getting. You know if the user clicking on you has a specific item on them, and then you can react to that. Okay. So now that we have the way to pick up a key, you want the door to open up, right? So Unity has a nice animation system that's perfect for this kind of stuff. I'm not going to go over it in too much detail. Again, I want to give everybody here an idea where to look in Unity, because I realize that you're going to be doing this on your own time and looking everything up and going, what did he talk about? Which system was it? Knowing that there's an animation system is the key point here. So when you get into the animation windows, what you can do is sort of say where your object is at the beginning of the animation and at the end. So in this case, we want these cubes to lift as if they were porticulines, anyway, like little portals opening up, and you want to animate them going upward like that, and I made the little touch of changing the color as it was going up. You'd obviously be making something a bit more fancy if you wanted like a full-on VR experience. So how do we animate things? How do we react to clicks? So the other thing the Unity animation system has is a nice little state machine that you can program like this. And you can sort of say, okay, I'm going to move from state A to state B and associate certain animations to each of these state changes. So you can build a lot more complex animations out of this, but here it's only really about opening the door and closing it, right? So when you click, you move from one step to the other, that's about it. So if we take that all together, we can see sort of how the state machine changes states when it gets clicked on with the right color, and when it clicked again, it closes the thing. One small takeaway I like to give people that took me a little while to discover with Unity, if you want to reverse an animation, you set a negative factor. So if you want to move from one state to the other, it's like 1, your speed of animation is 1, and if you want to reverse that, your speed of animation is -1, which is not necessarily intuitive if you don't know this when you're starting out. All right, anyway. So there you have it. That's the software side of things. And that covers most of the tools that we teach in our community workshops at Osmos right now. Obviously, we're always trying to find new ideas. We have a lot of new ideas. Actually, we try to implement those new ideas, I should be saying. So if you're interested in building similar things, and we're on a share tools, we have like a lot of knowledge here that we are really willing to share and are always looking to put in a Git format that's easily digestible, which is usually the biggest challenge, I would say. But what I would like you to do, if you're interested in this stuff, is contact me after this talk, and we can share contact information, and we can start a little dialogue and try to help you along and share experiences and try to just like make friends. All right. So with that, thank you very much.